In this video, I'll be solving the third problem of JEE Advanced 2025 first paper. So we were given a matrix P 200020003 and we are asked to find different invertible matrices, number of possible different invertible matrices Q with integer entries such that Q inverse is Q transpose and PQ is Q times P. So first, like if we consider, like let's say Q is some matrix A11, A12, A13, A21, A22, A23 and A31, A32, A33. Now like P times Q is equals to Q times P. So that means 200,020,003 into A11, A12, A13 is A21, A31, A32, A33. So this is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33 into 200,020,003. Now if we simplify this, so I think like the first row elements are 2A11 and 2A12 and 2A13. And the second row will be 2A21 and similarly 2A22, 2A23, 3A31, 3A32, 3A33. And that is equal to, similarly if we multiply on the right hand side, we'll get 2A11, 2A12, 3A13, 2A21, 2A22, 3A23 and 2A31, 2A32, 3A33. So if we consider this 3 cross 3 element, that is same, and even the 1 cross 2 to 2 cross 2 elements, they are also same. So the only differing elements are these. So that means 2 times A13 is equals to 3 times A13. 2 times A23 is 3 times A23. 3 times A31 is 2 times A31. And 3 times A32 is 2 times A32. So that means A13 is 0, A23 is 0, A31 is 0, and A32 is 0. So our Q is of the form A11, A12, 0, A21, A22, 0, 0, 0, A33. So, and we were given the other condition that Q inverse is Q transpose, and we were given that Q is invertible. So that means Q into Q transpose is I. So that means Q is an orthogonal matrix. So now like if Q is an orthogonal matrix, so A11, A12, 0, A21, A22, 0, 0, 0, A33 into transpose of this particular matrix is A11, A21, 0, A12, A22, 0, 0, 0, A33. So that is equals to the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Now that means A11 square plus A12 square, A11, A21 plus A12, A22 and 0. And the second row will be A11, A21 plus A22, A12 and A12 square plus A22 square and 0, 0, 0, A33 square. So that is nothing but 1, 0, 0, 0, 1, 0, 0, 0, 1. So that means A33 square is 1. So that means A33 can be either 1 or minus 1. And A11 square plus A12 square is 1. Comma A21 square plus A22 square is also 1. And finally A11, A21 plus A12, A22 must be equal to 0. So now like if we observe like these two, so from this like we can say the number of possibilities will be, so out of this A11, A12 and out of this A21, A22, one must be 0. and the other must be 1. So out of those 2, I am choosing 1 to be 1 and I am choosing 1 to be 1. So basically, like choosing which to be 1 times, I'm doing it 2 times because like once it is 1, so the square is 1. So if the square is 1, the each element can be either 1 or positive, negative 1. So it can be 1 or negative 1. So for that I am multiplying it by 2. Now we also need to take this A3 into account. So into 2, like this I am doing it for A3 because A3 can be either 1 or minus 1. So these are the different values of Q. So 2 into 2 into 2 into 2. In total we find like around 16 matrices for these two conditions to be possible. So that's it for this video.